Good morning, mathematicians. It is week 10. We are starting with our Monday column, and I hope you have your glasses on because we have some very small cubes that we're going to be counting today, and every single question relates in some way to a volume standard. So let's get started. Number one says, what is the volume of the figure below? And we look and see right away that it is an irregular shape because we have a rectangular prism on the bottom, but then we have these one, two, three, four cubes that are kind of stuck to the very, very top of it. Now, since I see four cubes stuck to the very top, my strategy is to find what the volume of the bottom layer is and then add four more, right? So let's take a look at this length. We see one, two, three, four, five. So this has a length of five. I see one, two, three, four. I see this has a width of 4. And of course, this particular column has a height of 1 because there's just one layer that is completely filled in. So this bottom layer, I know 5 times 4, the bottom layer is going to be made up of 20 cubes. There's 20 cubes in the bottom layer. And then what did we say about that irregular little flat line on top? That was going to be 4 on top. Well, I know that 20 plus 4 means that there will be 24 cubes. And in this case, we will report those as cubic centimeters. Now, that finishes out number one. But notice we can use this idea to help us with number two, because when I study the length of this, I notice it also has a length of 5. When I study the width, I notice that it also has a width of 4. And in terms of the layer being completely filled in, that bottom layer is the only layer that's completely filled in, right? Then we have 4 that are stuck right here in a line. And here we have double that. So we have 8 that are stuck in a line here. So what I notice is that this shape is exactly like the bottom layer here and these random 4 stuck to the top. So really the difference between this first one and this one has everything to do with these additional 8. So I can really take the 24 from number 1 and I can add 8 more to find the volume of this. If you follow that thinking, you save yourself a little bit of extra work, and we know that our answer is 32 cubes or 32 centimeters cubed. All right, let's go to our next one. And our next one does not relate as heavily to number one or two. We're really going to have to go back to creating a problem solving strategy. So I'm going to start noticing some of the attributes of this irregular shape. I see one, two, three, four, five, six, seven. I see this has a length of 7. I'm going to double check it. Always a good idea to double check when your cubes are just so small. One, two, three, four, five, six, 7. Yes, this has a length of 7. Now here, this is very small, so count carefully. I see one, two, three, four, 5. Notice it was a little easier to count them on top, but I know that the width of this is exactly the same as the width of this, so that was a great way for me to do it. Now, I want to look very closely and notice what the height is of the regular prism that's on the bottom. And then, yes, we're going to have a little bit of extra stuff here. We have kind of another prism stuck here and another prism stuck here. So I'm going to notice first that I have one, two, three. So this has a height of 3, right? I could go ahead and find the volume of that and then add these extras that are stuck on. Or alternatively, I could pretend like this has, instead of just one, two, three, a height of 3, I could make this have a height of 5. I could calculate the volume of this as if it's completely filled in, and then I can account for these missing cubes that are here and here. Whichever way you want to do it works. We'll arrive at the same answer if we do the same work. I'm going to go with kind of overcompensating for it, pretending like it's a continuous shape, and then I'm going to subtract my missing cubes. So with that, I'm going to have a height of 1, 2, 3, 4, 5. Remember, we said the first 3 are truly a continuous prism. And then at the top two rows, that's where really I'm going to have some holes. And I'll account for those later, right? Now, did I have a width of 5? Look, 1, 2, 3, 4, 5. Yes. So I have a width of 5, a length of 7, and a height of 5. I know that volume equals length times width times height. So volume equals 7 times 5 times 5. Well, 7 times 5 is 35. I need to do 35 times 5 in order to figure out that part. I'm going to come to the side and do that. 35 times 5. 5 times 5 is 25. Here's my 5, carry my 2. 5 times 3 is 15, plus 2 more is 17. So if this were a continuous prism, rectangular prism, then it would have a volume of 175 centimeters cubed. Now, what I have to do is now have to go back and I have to account for the fact that some of these are missing, right? Now, the question is, how many are missing? Well, how many did we have right here? We had 1, 2, 3, 4, 5 cubes right here. But that there's actually two layers of those, right? Because here it's just one line that goes straight down, but I have 5 on the top and 5 on the bottom. So I'm going to need to subtract the 10 cubes that are missing from here. And then over here, I'm going to have to subtract another 10 missing cubes because I also have 5 on the top and 5 on the bottom that are missing. So in all, what we have to do is we have to subtract for 20 cubes that are not really there in the shape. Now, when I do that, I get the actual, oops, excuse me. When I do that, I actually get the actual number of cubes that I have, which is 155. And what is it? It's 155 centimeters cubed. So we are done with our first 3 volume questions, but guess what? There's one more volume standard that we're going to think about. This relates to standards, but it really heavily relates to layering and layer structures in our prisms, which is one of my favorite things to think about when it comes to our volume standards in 5th grade. This says Mr. Feast makes a prism with a bottom face measuring 6 centimeters by 4 centimeters. He then adds layers to the prism. Fill in the chart below with the volume of each prism that she made. Finally, write an equation to show how you found the volume for each. So if the prism only had one layer, what would the volume be? Well, we know that it is one layer. Let me switch colors actually for this one. We know that it is one layer of 4 by 6 centimeter blocks, right? Because it said that it measured as a 6 by 4. So if it is 1 times 6 times 4, we know that it has a volume of 24. And yes, it's really 24 centimeters cubed. But for the sake of the tiny chart, we're just going to write it as 24. Now, they went ahead and typed in or wrote in what the equation would be. If it were 3 layers, instead of 1 times 6 times 4, it would be 3 times 6 times 4. So really, I need to take this number, and I know that it's going to be 3 times bigger than that because there's 3 of those layers. Well, 24 times 3, I know, is 72. Now I need to do the same thing with 8. So if I have 8 layers, and I have 8 layers of the 6 times 4, what would that be? Well, I know that 6 times 4 is 24, but I know that I'm going to have 8 of those. So let's multiply to find that. 8 times 4 is 32. Here's my 2, carry my 3. 8 times 2 is 16, 17, 18, 19. I am looking at 192 cubes in those 8 layers. My last one that I'm going to have is 10. If I have a large prism and it has 10 layers, and those layers are each a 6 by 4. If I have 6 times 4 is 24, and I multiply that by 10, I'm going to have a 24 with a 0, 240. So that finishes out this Monday